Greetings, welcome to this new video about dependent source circuits analysis. Solve the problem number 11. Let's consider this network consisting of two resistors labeled R1 and R2 along with two independent current sources IA and IB. Additionally, we can observe the presence of dependent sources, especially a voltage controlled voltage source and a current controlled current source. The question now is to calculate the node voltage values V1 and V2. Let's move on to the solution. We are going to apply the mesh analysis method to solve this problem. First, let's begin by defining the number of meshes in this network. It's evident that there are four meshes: mesh 1, mesh 2, mesh 3, and mesh 4. Now let's proceed to assign the mesh currents in this network, and I will consider I1 is the current in mesh 1, I2 is the current in mesh 2, I3 is the current in mesh 3, and I4 is the current in mesh 4. All the mesh currents are chosen in the clockwise direction. Let's start first with mesh 1. We can see here in mesh 1 that the current I1 is equal to IA, and we know that IA is equal to 20 amps. That means I1 is equal to 20 amps. Let's move on to mesh 2. By applying Kirchhoff's voltage law in mesh 2, we can write R1 I2 minus I1 plus 2 Vx is equal to 0. And according to Ohm's law, we have Vx is equal to R2 I3 minus I4. If we replace that in the first equation, we obtain R1 is equal to I2 minus I1 plus 2R2 I3 minus I4 is equal to 0. By replacing the resistors with their numerical values, and if we continue simplifying this equation, we obtain negative 10 I1 plus 10 I2 plus 40 I3 minus 40 I4 is equal to 0. Let's move on now to mesh 3. We can see here in mesh 3 that the current I3 is equal to negative 4 Ix. And we know that the current Ix is equal to I1 minus I2. That means I3 is equal to negative 4 I1 minus I2. If we continue simplifying this, we obtain I3 is equal to negative 4 I1 plus 4 I2. Let's move on to mesh 4. We can see here in mesh 4 that the current I4 is equal to IB. And we know that IB is equal to 7 amps. That means I4 is equal to 7 amps. From question 1 and 3, we can write I3 is equal to negative 80 plus 4I2, and by substituting A, 1, and 4 in equation 2, we derive one equation in terms of I2. And if we continue simplifying this equation, we obtain negative 3680 plus 170 I2 is equal to 0. That means I2 is equal to 3680 over 170. We get I2 is equal to 21.647 amps. And we know that Ix is equal to I1 minus I2. We know I1 is equal to I2 is equal to 20 amps, is equal to I1 is equal to IA is equal to 20 amps, and I2 is equal to 21.647 amps. Then we obtain Ix is equal to negative 1.647 amps. And from equation 3, we have I3 is equal to negative 4I1 plus 4I2. If we replace I1 and I2 with their numerical values, we obtain I3 is equal to 6.588 amps. Let's move on now to the node voltage V1 is equal to 2 Vx. And we see that this branch is in parallel with this branch. That means V1 is equal to R1 multiplying by Ix. If we replace R1 and IX with their numerical values, we obtain V1 is equal to negative 16.47 volt. Let's move on now to the node voltage. V2 is equal to R2 I3 minus I4. If we replace R2, I3 and I4 with their numerical values, we obtain V2 is equal to negative 8.24 volt. After we finish, or after completing the calculation, we conduct a simulation using SPICE to verify our result. Now let's proceed to the SPICE environment. Here is our circuits or our network drawn in SPICE simulator. This is the current source IA 20 amps, IB is 7 amps, and we see the resistor R1, R2, and the voltage controlled voltage source and the current controlled current source. In order to measure the node voltage V1 and V2, I connect here a voltmeter to V1 to measure the voltage source, the node voltage V1, and I connect here the voltmeter to measure the node voltage V2. Let's move on to analysis. This analysis calculates nodal voltages, and we can see here that the V1 is equal to negative 16.47 volt and V2 is equal to negative 8.24 volt. Those values are the same value or similar to the value we have done by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video. Take care and bye bye.